and I'm here to talk about autoscaling on AWS. I work for Mass Relevance as a software engineer. I've been there for about a year, and we serve a huge amount of traffic, so we definitely put this service to the ringer. And I guess I'll get started. So what is Amazon's autoscaling? Well, put simply, it's a way for you to automatically launch and terminate EC2 instances in Amazon. And if you don't know already, an EC2 instance is a virtual server that you can launch on the Amazon AWS platform. And it's actually a really nice service because it allows you to save money by only running the instances that you need when you need them, rather than running like a huge infrastructure that can handle pretty much any traffic load and waste a lot of resources when it's not handling large loads. So, what makes up autoscaling? Well, it's basically comprised of several different services that come together in concert to automatically adjust your environment to meet your needs. These are the four basic ones right here. There are some more that I'm kind of glossing over, but fundamentally this is kind of what you'll be using to set up the basic autoscaling group. So it's watch configurations, autoscaling groups, scaling policies, and CloudWatch Alarms. And each one of these in detail. The first one, launch configurations, are templates that describe parameters passed at boot time to your EC2 instances. These are things like, what image do I boot off of? How big is my instance going to be? You can even define things like spot price if you're going to take advantage of the spot pricing auctioning service that Amazon offers. So the next component is the autoscaling group itself, and this is basically just a set of EC2 instances that run a launch configuration. I'll get to those in more detail later. The third component is the scaling policy, and this is a template that defines actions to take against an autoscaling group. So, for example, start two instances in the autoscaling group called web servers is like a perfectly valid scaling policy that you can use. And the last component that I'm going to talk about is CloudWatch Alarms, and these are triggers that can run the scaling policies based on metrics that you're monitoring across your environment. So how do these components work together? To illustrate how they do, I'm going to walk through a really simple example of setting up a very simple web application service. And I'm basically going to use 5 steps to get there. And the goal of this exercise is to get to a point where I have an environment that can scale up based on CPU load and scale down when the CPU load is low. A few prerequisites up front though. You're going to need an AWS account because you're probably not going to get very far unless you have one of these. I'm also going to assume that I'm already running like a web application on an EBS back instant. Now that's not a requirement, but it certainly makes explaining some of the basics a lot easier because EBS is a disk as a service that you can take snapshots of, clone, copy, and make other instances from it really, really easily. And all my examples are going to use the new AWS command line tool. If you haven't used it, it's actually pretty sweet. Like, it even ships with these awesome like ZSH autocomplete things. So like if you don't remember a command, you just hit tab and it's like right there. They also ship one for Bash too, but I won't use that because that's old stuff. So step one, I'm going to create an AMI from my already running instance. I'm just using the example with an instance ID of I-1234567. Hopefully I'm running a web service on there that's pretty tolerant to restarting, something that I can turn off and turn back on without it like just killing all the active connections to it and such. Hopefully something that has like a decent load balancer check too, because I'm going to be using one of those in this example. But for the most part, once you run this command, it's going to spit out an AMI ID that will represent the disk that I can create new servers from. I'm also going to create a load balancer, and this command here is going to create like an empty load balancer that will listen on port 80 using the protocol HTTP and just forward HTTP requests to port 80 on any instance that's attached to it. So once I have these things in place, I can create a launch configuration to describe the parameters that I want to pass to this actual servers that are going to be running my autoscaler. So this one right here, some of the things that you should take note of is that you have to pass to it any parameter that you would need to boot an EC2 instance. And if you've ever used the dashboard before, you'll find that these correspond to a lot of the little drop-downs and stuff that you actually have to put in there. things like SSH key, which security group that you're going to be running it in, pretty standard stuff, what instance size you're going to run. So actually, launch configurations are really simple. They can get more complex, but this is a very, very basic example. So once I have my launch configuration, I can create an autoscaling group and attach the launch configuration to it. So there's a lot of parameters that you actually pass to an autoscaling group when you create these as well, things that are pretty important, like the minimum number of instances that will be running. With the min size of 1, that means this autoscaling group will never be running any less than 1 server. And with a max size of 10, it will never be running any more than 10. There's also a couple other parameters that I should probably talk about, like default cooldown. This is a handy little parameter that allows you to introduce a wait time between when an event takes place and when the group will allow another event to take place. And that's because, if you boot a server, it's probably going to be using a lot of CPU resources. You probably don't want to trigger your alarms to start new servers. Some other things to note here, the health check type is set to EC2. This actually can be one of 2 different things. EC2 is kind of an internal check that Amazon uses to make sure that the instance is healthy, and if it's not, then the autoscaling group will automatically just turn off the instance and start another one to replace it. This can also be set to ELB if you want to use the health checks defined on your load balancers. But that is kind of a mixed blessing because maybe you want to stop your web service without it being totally terminated in your autoscaling group. So once I have all these things in place, I actually have a pretty decent configuration. I could actually stop here and just use the command line tools to start and stop servers, and it would work pretty well. I can just say, autoscaling tool, add 2 servers to this group, and it will just launch 2 based on the parameters that I actually set on it already. But I'm going to take it a little further and talk about the real greatness of this, and that's the scaling policies and the CloudWatch metrics. So I'm going to create 2 policies. The first one is going to increase the number of instances running in the autoscaling group by 1. And you'll note here that I can actually override the cooldown that I actually specified in the group. And for every autoscaling policy that you write, you can actually overwrite that. And it's kind of nice because in some situations you may want to wait longer on scale down events than you do on scale up events to prevent you from just terminating instances prematurely if there's a little wall in traffic or something like that. Similarly, this command will create a policy that tells an autoscaling group to reduce its size by 1, which will basically just terminate an instance in it. Now, every time I run one of these commands, it's going to spit out this giant ARN string, which is an internal reference that Amazon uses to uniquely identify objects and services in its environment. And I'm going to need to take these down for later because this is how my CloudWatch metrics are going to map to these policies and tell them what to do. So once I have those 2 things in place, I can create the actual CloudWatch alarms that will trigger these policies to run. And notice the alarm action. This is the policy that I defined before that said bring the autoscaling group up by 1 instance. Some other parameters here to note too are some of the different ways that you can measure the CloudWatch things that the alarm will trigger off of. In this example, I'm using a statistical average over 5 minutes, and if it's greater than 60, greater than or equal to 60 over 5 minutes, and that happens over 1 5-minute period, then it's going to execute this autoscaling policy and launch 1 server. Similarly, this is the other side of the equation. This is the policy that will define reducing the autoscaling group by 1 server when the threshold falls below 50% CPU, averaged across the entire autoscaling group. Any questions so far?
Quick question.
Yeah.
So one thing I've noticed when I played around with this is that for this scale down alarm, it's always a trigger because SQL CPU is less than 20%. It happens a lot, and so it's always in a state of being triggered.
Yeah. Oh yeah, there's a lot of our services that just sit there in the alarm state, especially late at night when they're low. I mean, it's perfectly acceptable. We don't really have them sending SNS notifications to us to indicate that they failed.
I just wonder if there's any kind of tricks so that it's not triggering.
You could actually disable the policy, on the schedule or something like that, as an observer to do it. for the most part, it's just really the period. The period.
Well,
Well,
in the period, I don't know
the default is, I believe it's 1, but yeah, you can increase the period too, so that it will, you could say, don't execute this policy for like 25 evaluation intervals, and then you just won't do anything until all of those actually pass. Yeah.
I have a weird old trick.
Yeah.
So you're watching CPU is you can actually use any metric that you've collected to attach an alarm. You don't necessarily have to watch CPU. You could watch something like number of open connections, number of completed things. Maybe you're trying to get a certain throughput somewhere. If you're collecting those CloudWatch metrics on your actual instance, and you can actually describe it here is shown out the average statistic. You can also use the sum statistic or any other statistics you can actually throw in the CloudWatch and watch and monitor to denote when and where you want to actually scale down. Same works for scale up.
Yeah, that's absolutely right. It's kind of like this namespace here actually indicates that I'm looking at metrics across AWS and EC2, mainly CPU utilization across the nodes that I'm running, but you could also look at namespaces of like ELBs and look at the number of connections flowing through a load balancer. There's like so many metrics that you can actually like use to trigger your autoscaling. It's actually pretty phenomenal. This is a real basic example that just uses CPU, and for the most part, we kind of use that more than anything else, just because it seems to be the best indicator of when we need to scale. But we could probably easily use something else too, like database load, for example. It's perfectly simple. Any other questions before I proceed? I know I'm going pretty fast. So that was pretty much it. Like after I run all those commands, I now have an auto-scaling group that will scale up and down based on CPU, which is in 5 easy steps, and I'm good to go. Unfortunately, auto-scaling doesn't really have like a good GUI tool to do this. But one of the components that actually does is the CloudWatch console. And once you set up your group, you can actually go in there and look at all the alarms that you've set. And this is kind of an example from our production environment. We actually have several different autoscaling alarms that have been set. As you can see, they're in this kind of like low state, like pretty much all the time at night. The red lines indicate the thresholds that they cross to trigger the alarm. Yeah, it's pretty nice. You can like look at the histories of the things that they fired as well in the console. It's all pretty much easy to use. And you can even update them and save and all that stuff. So here's kind of an example from an event that happened on the 29th. All our servers run GMT, but as you can see, the load basically tripled like all of a sudden, and we weren't even aware of this really going on. Autoscaling just kind of took care of all this for us, and we can sleep at night and not have to worry about turning on our servers to handle like random stuff. I think this was actually one of our customers doing a load test on us. They do that from time to time, and we're usually just fine. So it's really nice.
I have a question.
Yeah.
So if it spikes up at such a high rate all of a sudden, I mean, you mentioned about one spinning up one server. How do you dynamically spin up or decide? Say spin up 20 servers or 30 servers?
It's definitely been more of an art than a science, like in our environment. I get to more detail about what we're actually doing in our environment in a little bit, but for the most part, things on EBS tend to boot pretty fast. Netflix, I guess, just released something today that like removes a bunch of like autoscaling stuff for you. In general, our instances take about 3 minutes to boot, so we can usually have additional capacity like really quickly. You can play around with the thresholds that you alert off of to like just keep launching instances over and over again until you actually can like survive the load that's being handed to you. In our environment, our scale-up policies tend to be pretty generous. Like we don't have a lot of cooldowns there. Like we just go ahead and like scale it if we can, just to handle the load, and it's been working pretty well for us. We also do a lot of caching on CDNs now, which helps, but creating AMIs for your instances is a really like if you're using something like Chef or something like that, it could take a really long time to spool up an instance. So that's one of those situations where you think about caching an AMI or making a small snapshot. Ralph?
One of the problems people run into with autoscaling that I've seen before is they try to use the smallest instance they can do, and so when they scale up, they need to scale up like 8 to 12 or 16. If you start looking at some of the larger instance types, that helps when you're bringing on more capacity per increment.
Okay.
I often have fantasies about replacing our Symantec web servers with just like one giant CC2 8XL. I'm done with it forever. Yeah.
So I'm new to AWS, this is probably
Yeah.
a totally novice question, but
Oh,
in
sure.
terms of scaling across, like, redundancy across logical and geographic groups, I'm just coming out from here a couple of years ago, one server and the server went down. Does this handle that pretty automatically in the sense of scaling or setting up across different, I guess, logical groups so if one goes down?
So yeah, actually, now across regions, you can't really use autoscaling policies. For example, if you have servers in Virginia and servers in California, you can't have an autoscale policy measure the performance of the server in Oregon or vice versa. So they tend to be fairly geographically isolated. But within an Amazon EC2 environment itself, you can measure across all of the availability zones that are in that particular geographical region. So we tend to run ours instances in about 3 regions, maybe 2 now at this point.
Might need to go into what these are.
Yeah, so AZs are basically like data center buildings. You can think of them as data center buildings in Virginia, for example, for US East. You'll have 4 availability zones within that unit. If one goes down, chances are some of the other ones are working just fine because they're fairly isolated. Now, granted, if all of Virginia like sent into the ocean for some reason, then we'll lose all of them.
So across ACs, but not across regions?
Yeah, so across AZs you're good, but across geographical regions like all the way to Oregon or something like that, they're pretty messy. Yeah.
I don't know if you can get to this later, but how do you handle deploys in an environment like this, getting new code to these servers as they're dynamically growing?
Yeah, actually, I'd love to talk about that later. I don't explicitly cover them in the slides, but at the end of the presentation, just ask me and I'll go into kind of what we do there. Actually, that's kind of a good segue into this. In the example I gave, I was using AMIs, and that's one of the things that we don't use in our environment at all. We actually use Chef to provision all of our instances, and that takes an instance from like bare metal all the way up to running production code by running a series of like controlled scripts that get it there. And we actually do like create snapshots of these things every once in a while just to like make the process faster. But for the most part, we could actually start a server that was running absolutely nothing and fire it up in our autoscaling group, and it would be ready to run production code. Probably from total scratch, it would take about 20 minutes or so. So if you don't have an AMI to boot your stuff off of, Amazon actually has you covered there because there's this concept called user data scripts. And what user data scripts are is a very small script that you can pass to your instance. It's just written in Bash, and it'll execute it when the server starts up. That script can be kind of an entry point into getting other scripts, downloading packages, that kind of thing. And actually, in our environment, we have a lot of more sophisticated configuration tooling stored on S3. So Amazon has this concept called an IAM role, which allows servers to start up with a certain level of permissions that you can grant to other resources. So in our environment, essentially a server will come up, it'll execute a little user data script, and because it's in an IAM role, it will have access to a private S3 bucket that actually contains the Chef client. It will contain the certs and all those kind of things that it needs to actually start communicating with the configuration management server. It'll download those and kind of start executing them immediately. And I have like kind of an example of this is actually our script with some S3 bucket name changed to things to protect the innocent. So yeah, a user data script can only be like I think 1024K, but that's just enough to like download the S3 command package, install it, grab a script off S3, kick it off, pass it a roll, and then it's good to go. So we've used this technique for pretty much all of our autoscaling groups, and it's been really effective for us. We've managed to scale like upwards of 200 servers to handle the Grammys, where we were doing 80,000 requests per second. And then like an hour after it was over and nobody was using the site anymore, we scaled down and we were running like maybe 10 servers. So anyway. So that's kind of a brief overview. I wanted to give a lot of time for Q&A so that if you have advanced questions like deployment, which I guess I'll start by answering, then yeah, now's the time to do it. So to answer your question first, so our deploy scripts, when executed by our build server or executed by an individual developer, actually probe Amazon, because everything on Amazon has a nice API that you can just grab like JSON blocks out of and parse. And it actually finds out all the servers that it should be deploying code to. It actually does some heuristics to figure out how many servers it should deploy to at once. But it generates a giant list of servers fundamentally, and just kind of iterates through them and deploys code to all of them, gracefully removing them from the load balancer and putting them back in.
Do you have a challenge then with, as a new server is being provisioned, it might not actually be ready for that code yet? Is that a problem that you face, and so how do you resolve it?
It hasn't really been a problem that we face because our chef scripts take it all the way to being able to run code before any code actually gets deployed and returned to it. But our deploys actually update a key in S3 that indicates which SHA has been deployed or is being deployed on all the servers. So if an autoscaling event